Hey there, welcome to Unit 1, Lesson 3b Notes. That means we're doing the second half of Lesson 3 today. We're going to continue simplifying radical expressions, and today we will look at just conjugates. We will use conjugates to simplify radical expressions. So here, let's remind us the three ways to, the three ways to simplify a radical expression. Remember that a radical expression is under a radical symbol like that. So the first thing we'll check is that no radicands have perfect square factors. So we'll divide by perfect squares to help us get the factors out. Some of you liked to find the prime factorization by using a factor tree. That's totally fine. You can keep doing that as your special hint to help you. So remember, under our radical, we can't have any type of number squared. So we'll take our number and we'll split it into different factors until we know what's inside of it. Also, our radicands cannot have any fractions inside. That's like, you can't have a radical with something in a fraction inside of it. And finally, speaking of fractions, we say that no radicals are in the denominator of a fraction. That is, you don't have some fraction that's like a over the square root of b, like that. So again, the things to look out for are that you don't have an x squared, you don't have a fraction underneath the radical, or you don't have a radical underneath your fraction. What we did to get rid of that yesterday was we did a process called rationalize the denominator. That is, we made the denominator a rational number. We got rid of gross square roots, and we're going to do that still today. We're going to do a new process. Yesterday we looked at, what we're going to do today is we are going to multiply top and bottom by the conjugate. So you take the conjugate of an expression and you will multiply it by the conjugate divided by the conjugate. And that is our key idea right here. You're going to multiply top and bottom by the conjugate. And you're like, yeah, Miss Van Dyke, that's great. Ooh, what happened there? Gross. No, Phil, thank you very much. Okay. That's great, but I don't know what a conjugate is. Or maybe some of you are saying, I know what conjugate means. Conjugate means to make a verb correct. So instead of saying, yar, I be a pirate, you would say, I am a pirate. But today we are not talking about verbs. We are talking about mathematics. So first, let's talk about a binomial. You might have used bifocals before. You might have ridden a bicycle or whatever. Used binoculars. Bi means two. And then nomial means number. So a binomial is an expression with two numbers. So a conjugate of a binomial basically flips the sign. So if you have a plus b, the conjugate then is a minus b. That's literally it. A plus b to a minus b. And then you can go the opposite way too. If you have a minus b, the conjugate is a plus b. Super duper, that's it. That's what a conjugate is. You flip the sign around with two numbers. So following this pattern, let's find the conjugate of a plus 2. Remember, look at the sign and flip it around. So the conjugate of a plus 2 is a minus 2. Let's get number 5. Remember, flip the sign around. What is the conjugate of 5 minus b cubed? It's 5 plus b cubed. What do you think is the conjugate of c plus the square root of 7? That would be c minus the square root of 7, because we took that plus and we switched it to a minus. And then finally, what is the conjugate of 8 minus rad 23? It's 8 plus the square root of 23. Because we took the sign, flipped it. Sweetums. Okay, cool, I can do this all day, but what's the point? How is this going to help us? Fantastic question, you guys. It's going to help us because it's going to give us a nice pattern. It will make our expressions look nicer. Because when we look at this square root of 7, that's irrational. It looks gross. Same thing, square root of 23, it looks gross. We're going to clean it up. We're going to use conjugates to clean up expressions like this. Okay? And to do that, we're going to use what's called the difference of squares shortcut. Now, the difference of squares shortcut says what happens when you multiply two binomials together. So we're going to times these expressions with two numbers. Now, please notice that they need to be the same number. So you need to have the same number plus one number and then the same number minus the number. So you have a plus b, a minus b. And that is going to work out to be a squared minus b squared. If you want to know why that works, please ask me in class and I would love to go over it with you. Also, we will look at this more in depth later this year. But we call this the difference of squares because when we look at math, difference means minus. And a square means some number, or whatever it is, some number squared. And you'll notice that's exactly what we have here. We have a minus, we have two squares. So let's put this shortcut into practice. Here on number 8, we have, on the one hand, 3 plus the square root of 5 times 3 minus the square root of 5. Does this follow our shortcut pattern? It does, because we have plus something and minus something, and they're multiplied together. Sweet. So here, let's identify what is our A and what is our B. Our A term, in this case, is 3, and our B term, in this case, is the square root of 5. So we can follow this same pattern. This is equal to A squared minus B squared. And again, our A squared is going to be 3. And our B squared is the square root of 5. So we took what is our A, which is 3, and we plugged it in right here. And we took what's our B, which is rad 5, and we plugged it in right there. Now let's simplify it a little bit. What is 3 squared? Oh, I forgot to say that's equals. 3 squared is 9. And the square root of 5 squared, guess what, guys? The square root and the square, they cancel each other out. So we just get 5. Yay! 9 minus 5 is 4. Super. So this whole expression, this whole thing right here, that's just 4. Isn't that great? See, it makes your life so much easier. Let's do one more. Let's take this pattern and bring it over. First of all, are we even allowed to use this pattern? Because here, we have minus and then a plus, but guys, guess what? That's okay. We're allowed to move our factors around, and it still works. There you go. So let's find out. What is our A term? Our A is the square root of 6. Whatever the square root of 6 is, I don't even know, but it's the square root of 6. And our B term is 5. What is 5? Well, it's the numbers of fingers I have on my hand. There you go. So now let's plug it into our pattern. A squared is the square root of 6 squared. B squared is 5 squared. The square root of 6 squared is just 6 because they cancel each other out. Cool. And 5 squared is 25. Oh man, 6 minus 25? That's negative 19. Oof. Hopefully you're thinking more positive thoughts than we got on our answer today. Cool. Again, just to follow up, every time we have an A, we placed a 6 there. And every time, the square root of 6, we placed the square root of 6 there. And every time we have a B, we placed 5 there. And it came out to negative 19. Sweet. Okay, so we know that we can use the difference of squares shortcuts to clean up some yucky numbers. That's awesome. We're going to use the same concept to help us simplify radical expressions with our conjugates. What color did I color code conjugate? I made it lilac. Alrighty, so we can use our conjugates to help us simplify radical expressions. The reason we can do that is their product is always going to be a rational number. It makes it rational. It rationalizes the radical expression. It's going to clean it up. Sweet, let's do it. Let's start it with number 10. So here, up on top, we have a nice 6, and that's great. I like it. But down here, oh no, we have 3 minus the square root of 2. Oh, sorry, I got ahead of myself. That's gross. So instead what we're going to do is we are going to rationalize the denominator by multiplying top and bottom by the conjugate. So we need to find out what is the conjugate of 3 minus the square root of 2. We're going to use the same players, 3 and rad 2, but we're changing this minus to a plus. Cool. And then on top, we're multiplying by the same thing, because remember, we're going to keep the value the same, so this is the same thing as 1, because whenever you have any number divided by itself, that's always 1. So 3 plus rad 2 divided by 3 plus rad 2 is just 1. And when you multiply by 1, you keep the number's identity the same. Okay, let's multiply. Let's clean this up and let's see what we get. Okay. Up on top, 6 times 3 plus rad 2. You guys, I'm going to leave that alone for now. 6 times 3 plus rad 2. Awesome. But on the bottom, we have a difference of squares pattern. Yes, because we have 3 minus rad 2 times 3 plus rad 2. So that's going to be the same thing as 3 squared minus rad 2 squared. Sweetums. In case you like colors to help you, our A term here is 3. And our B term here is rad 2. So we followed our pattern. I'll bring it down again so you can see it. Hold on. So we're following this exact same pattern. We have minus and plus, so that equals the difference of their squares. Cool. Okay. Now let's take this exact same guy and clean him up a bit too. I'm going to get rid of the colors so it's not distracting. Okay, first we're going to use the distributive property, red. We're going to use the distributive property to multiply 6 times 3 and 6 times rad 2. So up on top, that gives us 6 times 3 plus 6 times the square root of 2 all over 3 squared is 9. The square root of 2 squared, remember, the square root and the 2, they just cancel out. So that gives us a 2. And we're almost done. 6 times 3 is 18. Plus 6 times the square root of 2, we can't simplify it. All over 9 minus 2 is 7. And since 18, 6 and 7 don't have anything in common, that's our final answer. We are all set. Ooh, this barely fits in the circle, huh? Just barely. Now, to you, that might not look any simpler than our original expression, but we do not have a radical in our denominator. By the way, I bet you've been hearing how when I get a little flustered or when I hear that I'm misspeaking, I will go, You know who I picked that up from? I picked that up from my sister-in-law. So that's exciting. So careful how you speak and careful who you hang out with, because you will start to mimic them. Speaking of mimicking, go ahead and mimic that same pattern to simplify this radical expression. Our first step that we want to do is we want to multiply top and bottom by the conjugate of our denominator here. So let's start with the bottom and work our way up. Started from the bottom, now we're here. Okay, so that gives us 8 minus the square root of 5, and we need to multiply top and bottom by the same expression because we're multiplying by 1 because we are 1. So on top we're going to multiply all the way across, giving us 3 times 8 minus the square root of 5. And then on bottom we follow our difference of squares pattern. We've got 8 and we've got square root of 5. So we're going to plug those in to our pattern. That leaves us with 8 squared minus square root of 5 squared. Sweetums. Let's do 2 birds with 1 stone this time. We're going to distribute, I think I used this color, 3 times 8 and square root of 5, and we're going to complete this out. So 3 times 8 is on top minus 3 times the square root of 5, because remember we're doing a 3 times to both of our terms in our parentheses. Divided by 8 squared is 64. The square root of 5 squared is a plain old 5. Sweet. 3 times 8 is 24. 3 times the square root of 5 cannot be simplified. And 64 minus 5 is 59. And there you have it. That is simplified form. Amazing. We have one more. This one doesn't have any fractions involved, but I want to show you guys a nice fun shortcut when we have some variables here. So what we're going to do is we are going to split everybody into their own radical. So 25 will get its own little radical house, and then a squared will get its own radical, b squared will get it, or not, they're not, just b. B will get its own radical, and finally C4. That was not intended, but we'll see if you just have an explosion of knowledge here. Okay, so we have the square root of 25 times the square root of a squared times the square root of b times the square root of C4. Well, let's simplify this out. I'm gonna work down and we'll see how that goes. The square root of 25 is 5. Sweet. The square root of a squared is a. The square root of b we can't simplify anymore, so it's just the square root of b. Hey guys, c to the 4th power. You remember from your rules of exponents that c to the 4th power can also be rewritten as c to the 2nd power squared. Because when we have a power raised to another power, I skipped a step for you guys, didn't I? It's c to the 2 plus 2 with power. C to the power of 2 plus 2. However that works. However you say that, I don't know, I just know how to write it. So these expressions, these are all the same. When you have c squared, that whole thing squared, that's the same thing as c to the 2 plus 2 if power, which is c4. So we can rewrite the same guy as the square root of c squared squared. And then of course, the squared and the square root cancel out, just like this squared and this square root cancel out. So we are left with 5a square root of b c squared. And I'm going to rearrange this to move this guy over here just to make our lives a little bit neater. So our final answer is 5ac squared times the square root of b. And that's how it be. Time to let it be. Cool. I hope you guys have a wonderful time on your homework. Remember, this is your key idea here. We're going to use the difference of squares shortcut. Multiply top and bottom by a conjugate to to help us rationalize the denominator. There are 3 things that we cannot happen, that we cannot have happen when we want to simplify a radical expression. We cannot have a square, we cannot have a fraction, and we cannot have, excuse me, I was holding that hiccup in the whole time, and now it finally came out, right as I was about to say my last sentence. Oh well. We cannot have a square root underneath our fraction. Fantastic. Okay, you want to memorize this conjugate pattern right here. I hope you have a fantastic day. Good luck on your homework. Let me know if you have any questions.